Hey folks, this is the second part of the Section 3.2 Volcanoes Form as Molten Rock Erupts Notes. This is video E3.p3-10. We should have finished notes up through number 11 and number 9 video, so we should be right here in our notes. So I'm going to close this out and go to the PowerPoint. Okay, so most volcanoes form along plate boundaries. Number 12, they are very common along subduction zones. In fact, this is where we get our strongest earthquakes too. But subduction zones are where oceanic crust is sinking beneath continental crust because the oceanic crust is more dense than that continental crust. So we have this oceanic crust here, the Cocos plate, going under the Caribbean plate, and we get volcanic mountain chain on the continental side of this because of this friction of the oceanic crust subducting or going under the continental crust. Please note that this is exactly where we would get trenches too, where we have subduction zones. Number 13, they're also common along spreading centers, divergent boundaries where plates are pointed apart. Because remember when we talked about seafloor spreading, we said the plates would pull apart right here in the middle of this, where we can see the magma coming up. And once they pull apart, magma comes up, fills the gap, cools to form new lithosphere. Plates pull apart again, magma comes up, fills the gap, cools to form new lithosphere, again and again and again and again. And that's that seafloor spreading process. 14 says, less commonly volcanoes form over hot spots in the middle of plates. Magma from deep within the mantle melts rock in the lithosphere above it, and eruptions can then form island arcs, like the Hawaiian Islands, as the plate moves over the hot spot. The hot spot is specific to a certain point in the mantle. The tectonic plate simply moves over that, and in the Pacific Ocean, we see this manifesting itself as the Hawaiian Islands. New volcanic islands are always being formed, and the old ones are getting weathered away. We're not sure why hot spots happen, but they do happen in the middle of tectonic plates. The other very famous one is Yellowstone National Park. Some of you may not have known that, but Yellowstone National Park is actually considered a supervolcano, and historical records do speak of a very, very enormous volcanic eruption in that part of the world, and actually Yellowstone National Park has been bulging. In other words, the surface has been getting a little bit higher in that area. In fact, it's bulged about, I think it's like 10 feet over the last decade. And so we're thinking that this magma is getting even closer in that area, and we're getting closer to an eruption at Yellowstone National Park. So this right here is showing us hot spots and island arcs and showing the direction of this plate. So this whole plate here, the Pacific plate, we can see Pacific Ocean down here. We see the hot spot right at the first visible island in Hawaii, and that is Hawaii, the name of that island right now, as we can see right here. And all this we see out here, all the way to the Midway Islands, and actually up through the Emperor Seamount chain. Seamounts are underwater mountains. These were volcanic mountains at one point. So if we put this plate in reverse, whoops, I lost my cursor. We're going to go all the way back to Hawaii here. Okay, 65 million years ago, the Emperor Seamount chain here, Suiko, was right over the hot spot in Hawaii. Okay, so these island arcs are being created by plate movement over a hot spot. This is showing us the Ring of Fire. Johnny Cash would appreciate this. So here we are in North America, and here is our Cascade Mountain Range, showing us Mount St. Helens here in Washington State. But all these red dots are volcanoes. We have Hawaii out here in the middle under the and Ring of Fire. Are long subduction zones on the edges here, and that is the Ring of Fire. It's known as the Ring of Fire because of the intense volcanic activity and consequently earthquake activity. Okay, over 80% of the world's volcanoes and earthquake activity is right here in the ring of fire. It's pretty intense, and geologically, it's really neat. But it can be a dangerous place to live, obviously. Much more to come on sort of this diagram here. You're going to do a lot with that. Volcanoes can have many shapes and sizes. The shape of a volcano depends on the type of magma feeding it. Okay, so there's three types of volcanoes: shield, cinder cone, and composite, or the composite is also a stratovolcano. Same thing. So shield volcanoes. It says shaped like a broad, flat dome. Okay, this is low silica eruptions, and it's broad and flat because the lava is flowing long distances. So this is like the Hawaiian Islands. Largest volcano on Earth is a shield volcano, Mauna Loa, in Hawaii. Okay, because it's constantly spewing out lava, but they're just sort of nice, gentle lava flows, covering long distances. So it's not getting real tall, but it's getting real wide. Cinder cone, steep-sided, cone-shaped hill formed by eruption of cinders and rock fragments that pile up around a single crater. We most often see these on the sides of composite or shield volcanoes. They're really kind of neat. They're so neatly shaped because of the constant eruption of tiny little rocks and fragments and stuff. But generally, we see them on the sides of other volcanoes, not as an independent volcano. Composite or stratovolcanoes, they are cone-shaped. These would have the taller, steeper sides. These would look like more like just a plain old mountain because they are so tall. Magma is high in silica, which makes these the most violent eruptions because gases get trapped in that magma because it's very viscous. It doesn't flow very easily. Hardened lava can plug the opening, kind of like what we're seeing right here in this caldera. It gets plugged, and that also allows pressure to increase under here as gases are trapped and can cause big explosions. For example, Mount St. Helens exploded. It was so dangerous because they expected it to sort of blow its top and go straight up. And if it had, we probably would not have seen so many issues. But what happened was it was plugged, and a whole side started bulging out. And instead of going up through the top, Mount St. Helens blew out the side, which kind of screwed up their plan there on keeping people safe. More to come on that, though. So a caldera, which I actually just mentioned, is formed when the top of a shield or composite volcano collapses. So if we have this eruption here, you can see in the second picture that part of that magma chamber is emptied. It's hollow, and so now there's all this weight and nothing holding it up. It's hollow under there. So it collapses. And when it collapses, very often we can get a lake in there over time as it fills up with water. Crater Lake in Wizard Island out there. Crater Lake, very famous lake. A huge, huge lake, very beautiful. But it is actually called caldera from an old volcano. And 20. Scientists monitor volcanoes around the world for signs of eruptions like earthquake activity, increasing earthquake activity, that is, the amounts and types of gases that are being emitted, rising temperatures near the surface, because if temperatures are rising, that's telling us that magma is getting closer to the surface, and the types of rocks around the volcano to learn about the history. In other words, we can date these rocks to see how much time has passed between big eruptions. So we can figure out when we should expect another large eruption or activity out of a certain volcano. Volcanoes are somewhat predictable. Earthquakes are not. Okay, that's important to remember there. And hey, that's where we're stopping.